So space weather has got a profound influence on our own lives, our own quality of life, almost every day of our life. Although we live in the shadow of a star, the sun is actually the biggest supplier of energy in our solar system. Without the sun, the Earth would not have been able to sustain life, and life would not have been able to evolve on this planet. So the sun provides the energy, but let me see. Okay, when the sun sneezes, there's a great possibility that we on Earth, or the Earth planet itself, can get a cold. So for the sun itself, we've just heard in the previous presentation, it's located in the Orion belt, or the Orion Nebula of this Milky Way. It's roughly in the Middle Ages, 5 billion years old, with a 10 billion year expansion or life expectancy. With roughly 200 billion stars in this Milky Way, it's located roughly 28,000 light years from the center. It's actually a nuclear furnace. 10 to the 27-ton nuclear explosion taking place every day on a regular basis to sustain its own viability and not to collapse under its own center of gravity. The core temperature of 15 billion degrees Kelvin. Deuterium and tritium is being fused together to form helium at the rate of 700 million tons per second. Although it's a fairly small star, almost 1.3 million Earths can actually easily fit in it. It rotates roughly around about 27 days, which we call the synodic periodicity of the sun, and at a distance of 150 million kilometers away from us. It takes 8 minutes for the radiation to reach us. So every time you do sunbathing on a sandy bay, you just take and appreciate the fact that the sun that rays that actually reaches you left the sun actually 8 minutes ago. There are different spots and features on the sun that's both important that determines space weather. One is actually a solar flare. I haven't got videos loaded due to the problems that we had, so I wanted to show you how a typical solar flare looked like, but unfortunately it's not possible. These sunspots occupy vast areas on the sun, sometimes 200,000 kilometers in diameter. Coronal mass ejections is a feature of space weather during solar maximum. Then we have an increased number of sunspots. It's called the solar cycle, the 11-year solar cycle, and coronal holes are the features of what we see during solar minimum. So in fact, actually, oh, great, thank you very much. It actually operated, showing the nuclear explosion, it's a coronal mass ejection. And then a coronal hole is actually a large area on the sun that opens up, the magnetic field opens up. It's a primary form of space weather during solar minimum, and is the source of high-speed solar wind activity during solar minima. In fact, during this week, we actually had a incidence of high-speed solar wind activity, and I will show that if we come down to that later on in the presentation. So, solar activity, sunspots activity is closely related to the existence of magnetic storms, geomagnetic storms, and they correlate closely with the number of sunspots. And that is what we have our solar cycle. However, these solar cycles are not equally. They can extend over long periods of time. And actually, during the 1650 to around about 1735, we experienced a very long solar minimum period, abnormally long. It's called the Maunder minimum. Interestingly enough, it also coincided with a very cold period in Europe, but due to, if we look at the tree ring record in southern Africa, the whole Earth actually was involved or engulfed into a very cold period during that time. That made us scientists starting to think that there's a close relationship between the solar activity and normal weather. However, there's still a lot of controversy involved in that. I just want to mention during that time of 1600 to 1750, it's also the time when Stradivarius built his very famous string instruments, his cellos, his violins, and the wood that he used was hardcore rosewood that he collected during that time. So the theory goes that during that time the trees grew very slowly. The tree rings are actually very close together, close, and produced the wood unprecedented in the history of time. So basically what we actually see here is that the sun had a profound influence on the growth rate of trees and also then perhaps on the quality of the Stradivarius instruments that were built during that time. Sunspots form a very interesting pattern. When the solar cycle starts, it's at high latitudes, and as the solar cycle progresses downwards, it moves down to mid latitudes, low latitudes, and then disappear altogether and start all over again. That is what we call the solar cycle butterfly pattern. So what is actually happening at the moment with our present solar cycle that we are in? Solar cycle 23 has been completed. It actually, during that period, 2006, 7, 8, and 9, we had a very long solar minimum period with very little activity on the sun itself. The solar cycle sunspots dropped to a 100-year low. Total solar radiation dropped by 0.1%, which does not seem very much, but in terms of the radiation budget that reaches the Earth, it had a profound influence on tropospheric and higher activities and the chemical composition in the atmosphere itself. Cosmic rays, they dropped to very low, normally repelled by the solar wind. They actually surged to extreme heights during the space age. These events upended the normal picture of the solar minimum as actually being uneventful. But what is actually happening now at the moment? We are actually now going down in solar cycle 24. So what is the problem, or what is currently happening? Solar cycle 24 is declining more quickly than had ever been forecasted by models. 2018, the sun has been black for almost 60% of the time, and while whole weeks are going by without any sunspots to be determined. So the main question remains, will solar cycle minimum be longer or even be also unusual than whatever we have experienced before? So we have to wait and see, wait the space, and we might report something very interesting later on. This video will not be running because okay, thank you very much. But I haven't got sound, so that doesn't matter. We have to move on. This is how a magnetic storm actually evolves. Down here at the bottom is how a solar cycle or a solar storm actually started on the sun. There's an activity, a coronal mass ejection. The mass ejected by the sun is actually sometimes equal to the total mass of the Himalaya mountains. It impacted on the sun side, day side of the sun, of the Earth. It flows around the Earth's magnetic field and drops down through a process of reconnection, exciting the atoms, particularly oxygen and nitrogen in the atmosphere, and that is where we see our beautiful auroras in the northern and also in the southern hemisphere. Let's continue. Let's just summarize what space weather can have in store for us. All cars, ships, aeroplanes are equipped with GPS systems. We call them SUSI. Sometimes they're very angry, but they can be disrupted by space weather effects by influencing the path between the satellite and the receiver going through the ionosphere which is disturbed during a magnetic storm. So GPS is not always correct, particularly with very high resolution, where you require high resolution. For instance, the automatic landing systems of aeroplanes are equipped with, are relying extensively on a GPS system. So that can be affected. And during a magnetic storm, it can happen that these systems do not operate perfectly, and airline pilots have to switch over to manual landing procedures. Communication, it's also shortwave radio communication are vital to airlines flying particularly over the polar region, and that can also be adversely affected even for days on end during a magnetic storm. Geomagnetic surveys, we all know the Chinese are looking with very round eyes towards the mineral resources of Africa nowadays, and geomagnetic surveys for finding potential new resources of minerals will become very active in the near future. So these surveys rely extensively on the status of the magnetic field during a particular survey, because when the survey is being done during a disturbed period, you can find signals of gold where you actually coal was actually present. So that can create havoc with a geomagnetic or surveys. And then power line transformers, we all have evidence of extensive damage to power lines. Eskom is still struggling to provide us with normal power supply, and if that power line has been destroyed with a space weather event, even more havoc can prevail. It can even dump or put our own civilization at risk for many years when these power lines are actually damaged beyond control. High precision agriculture, the people planting mealies nowadays, the planting of the mealie pit or the seed and the fertilizer is at a critical distance from each other. So that relies on GPS systems that can also create unaccepted results. And satellites are in an area or a situation where they are directly hit by energetic particles from outer space. And then also radiation to airlines. It's common knowledge that at airline altitudes, your radiation levels are sometimes between 40 and 70 times more than you would experience at ground level. So those people who are actually actively searching for Voyager miles must also take into account that it comes at a price. And then I just wanted to show you the GPS systems that are on airlines, ships, and also for navigating the airlines. That they dial in a route on, say for instance, from Cape Town to London, and then that depends on how the GPS system actually operates. And if that medium, particularly the ionosphere between the airline and the receiving satellite, is disturbed, it can lead to a deviation in the route. And that also comes as a result of the dynamics of the ionized system between the satellite and Earth is being disturbed and can give erroneous readings on your GPS system. By law in South Africa, I'm not aware of all the other countries, but all airlines or all aircraft must be equipped with a magnetic compass. That is as a standby. It's not as accurate, but it can happen that these electronic systems can be struck by lightning, and then you can only rely on your magnetic compass as before. And shortwave radio communication is still the norm in the military for communication. And then also over the polar region, that is a very popular route between North America and Asia. And when you fly across this region, around about the 83 degrees, you have no communication satellites at all at your disposal. You only have the shortwave radio communication. And if that area or is disturbed through solar activity, geomagnetic storms, there's no communication possible for the airlines at all. So they have to reroute their routes in order to stay in contact with the bases at all. And that can sometimes exceed more than $100,000 US per flight. And it can have severe consequences for those airlines barely keeping head above water on their cash flow problem if they have to reroute at a cost of $100,000. Then I mentioned the damage to power networks. It is a result of a varying magnetic field. That is one of the laws in physics from Faraday. You have a varying magnetic field, it induces a current. And that current is quite lazy. It takes the shortest cut or a route available at that moment. And what nicer route is there for a long distance power line, particularly in the Scandinavian countries, but also at mid-latitudes where we live. There's evidence that these geomagnetic induced currents can actually damage transformers beyond repair, and they have to be replaced, and that is the size of these transformers that they cannot buy them off the shelf from Midas. You have to redesign them particularly for the specifics of a particular power network. I wanted to show you something about the magnetic storm of October 2003. That magnetic storm actually happened during the downward phase of solar cycle 23. Completely unexpected. It created it's actually the 8th largest magnetic storm ever recorded in mankind's history. So we used satellites, the SOHO satellite. SOHO stands for Solar and Heliospheric Observatory. It's located at the L1 libration point that is 1.5 million kilometers away from the Earth towards the Sun, where the gravitational field of the Sun and the Earth cancels each other out. So that provides 300 or 65 days observation of the Sun. So we've progressed quite a lot since Stonehenge, which was also built as a solar observatory. Nowadays we use a satellite. It's much more prominent and much more convenient with data availability on a continuous basis. That is the size of the sunspot that appeared on 29th of October. That is the size of the Earth. That we can see what actually made it even more dangerous. It was in a geo-effective position. That means it was directly in line with the orbit of the Earth. So it was actually like a shotgun aimed in line of the Earth. That is what we could see from the LASCO SOHO Observatory. That is a coronagraph, that is the size of the Sun, and this disk in front of the CCD camera actually blocks off the bright part of the solar surface, and we can only see how the solar corona actually behaved during that particular period. Here we see is the 26th of October, massive activity, and then all of a sudden here, around about 2030, that was when the energetic particles actually blinded the CCD camera of the coronagraph on board of the SOHO satellite. So that meant these particles were directed directly towards the Earth's magnetic field, and what happened then, we were just at the mercy of the solar magnetic storm. That is a result of a transformer damage at Ruacana. That is another one that got its best life behind itself. That was near Lesotho. And that is the index or the activity index for space weather as we recorded it on a planetary basis. So what happened during that particular storm? The ionosphere was so disturbed that the vertical error for the automatic landing technology on the aircraft was actually more than 50 meters. So that is what I said you had to use, or the pilots had to use manual landing procedures. Polar airlines had to be diverted to lower latitudes. and not even to speak about the human exposure to increased solar radiation. Even here in Southern Africa, we didn't escape the effects of the solar activity or the magnetic storm. That is the radiation alert issued by the Federal Aviation Authorities in America on October 28, 2003, indicating that pilots or airlines had to fly at lower levels in order to avoid the unexpected high levels of, and even Southern Africa did not escape that effect at all. So what do we do here in Southern Africa? Here at Hermanus, we have what we call a Space Weather Warning Center. We are part of 17 regional warning centers located worldwide, forming part of the International Space Environment Services. And we, at the southern tip of Africa, is the sole provider of space weather information for the whole of the African continents. That information regarding communications, navigation, and other effects such as geomagnetically induced currents. So that is just a scale to show you the different levels of disturbance in the Earth's magnetic field as a result of certain magnetic storms. Here at the G1 level, that is the lowest level, we can see that even migratory animals are adversely affected. And in the United States of America, pigeon flying is a highly lucrative industry, and these people fly pigeons that cost even more than $100,000. So if they lose these pigeons, it's quite a severe impact on the financial situation. So that means even with a less than 1% disturbance in the magnetic field of the Earth, it can have an impact on migratory animals. Then we go to higher levels. That is the top level. That is the Halloween 2003 storm. Is in that category. That's roughly around about 2% disturbance in the total field of the magnetic field of the Earth. GPS can be degraded for days. HF radio completely impossible, and so we can actually continue. Just illustrating how prone and how vulnerable our electronic and high technology systems are actually to impact and effects that actually started 150 million kilometers away from us. I just want to show some of the cost implications. $30 million in direct costs for the March 1989 magnetic storm. Satellites were damaged beyond repair, and then Polar Airlines, we know, had to dig up very deep into their pockets in order to prevent a loss of communication and also unnecessary or unwanted exposure from radiation. So what is the latest status? This week we observed, as I said, a complete blank sun with no sunspot activity. However, there was a coronal hole on the surface of the sun, which was a source of high-speed solar wind, roughly 560 kilometers per second. Proton density, 9 protons, is quite fairly high. And without even any activity like a coronal mass ejection, we recorded a G1 magnetic storm. That was the aurora observed at Tromsø in Norway, and that was simultaneously in Queensland, New Zealand. We could also see the aurora australis, and that is how the magnetic field behaved at Hermanus due to the impact of this high-speed solar wind on our environment. So nobody can escape the effects of a magnetic storm. It's not a high-pressure or a low-pressure system that will affect only localized regionals. The whole of the Earth is a victim of what happens on the sun. And that's, my dear friends, thank you very much in spite of all the problems.
Thank you very much, Peter. Much appreciated. And I do apologize for the delay, but we've sort of managed to get through most of it, I think. Are there any questions? Yes.
The equator of the rotation of the sun, is that oblique to the ecliptic?
No, not really. It varies according to the orientation of the Earth itself. It varies with the season. So it's not always the same. The ecliptic can vary with time, but not very much. It's a few degrees. It's actually more.
Yes.
Are you excited for the Parker Solar Probe to
Oh,
scientific observation?
yes, absolutely. It's on my to-do list, and the Parker Solar Probe will provide us with information unprecedented in the history of mankind. And we hope to observe stuff that we could only be dreaming of in the past, and now it will be possible to study in detail how the sun actually behaves and look into coronal holes and these coronal mass ejections of the physics behind the solar wind and the physics of the space weather itself.
Okay. Well, thank you very much, Peter.
Thank you very much.